Hello and welcome to AWS Made Easy episode number 95. I'm Stephen Barr.
Hi, everyone. I'm Rahul Subramaniam, and welcome to episode number 95. Again, just 5 away from our 100th episode that we hope will be something different and exciting.
Yes,
Can't believe it's
still
been that
in
long.
yeah, it's coming up. Yeah, it's still in the planning phases, but we are very excited for that. This is the show. For those of you who are just joining, we're glad you're here. This is the show where we interview AWS guests. We review AWS news in 60-second bits so you can quickly figure out, digest the AWS news fire hose and figure out what's relevant for you in terms of price, in terms of new features. And we review and rate those articles. And finally, we try to help you save however we can. Tools, tips, trips for helping you save.
And also, the AWS ecosystem is getting incredibly complex, and we help make it easier for you to digest all the news and information that's coming down that AWS fire hose. So hopefully, what we're doing is going to help you a little bit. We'd love your feedback. Send those across to us, and we'll try and make this show better for you. Okay. Why don't we get started, Stephen? How's your weekend?
Really good. I've been doing a lot of 3D printing. I've got a bunch of empty filament spools around here, finishing up the drawer system. But I had one of these really, really cool parenting moments where it all paid off. One of my kids, she was playing a board game, and in the board game, you have to hold these little tiles. And it came with a cardboard tile holder that was very unsatisfying. And so she ran down the stairs. I'm going to put the diagram she drew on the board, but she ran down the stairs and goes, "Dad, can you 3D print this something that will make it?" And she had dimensions on it, and then we modeled it in Fusion 360. We sliced it, we sent it to the printer, and in 20 minutes she was holding a prototype in her hand that was much better. So then we printed 4 more for every player in the game, and it was great. It was one of those idea to physical product in
an hour,
a very short slice of an afternoon. It was really happy. And it's a simple part, but it solved a problem.
Yeah. That's the wonders of 3D printing. That's awesome. Me, on the other hand, I am in Dubai. I would have typically said in warm and sunny Dubai, but yesterday and day before there was a massive thunderstorm over here. Parts of the city were flooded, but today it was bright and sunny. But as you can see out of my window, it's now pretty dark given the time zone situation. But yeah, I'm in Dubai for this week. It's been incredible, and looking forward to spending more time here. Again, time zone wise, it makes it a little easier to do these shows from here. So looking forward to this week. But yeah, enjoying the food, enjoying the weather over here. It's a lot cooler than Chennai.
I've never heard of someone going to Dubai for it to be cooler. That's incredible.
Yeah. So the beauty of Dubai is that starting about October all the way up to the end of March or early April, the weather is actually really nice. It is very cool. It's very outdoorsy. You're anywhere between, I'd say, 15 and 25 degrees centigrade, which is perfect weather to be outdoors. So it's been really nice outside.
So for our Fahrenheit friends, that is high 60s to low 80s.
Correct. Okay, so what do we have in store for the show today?
Okay, so we're going to dive into the AWS news and reviews. We're then going to do a bit of a deep dive and more involved discussion in vector databases. Finally, in the third half of the show, we're going to talk about EMR, how to save on EMR this is a simple one in theory, turning them off when you're not using them, but how to detect idle EMRs, turn them off, and you save some money there. So
got it.
We have a busy show. Let's dive into the news. All right, let's start with Article 1. First article, CloudWatch Metric Streams adds support for daily streaming of metrics. It's almost a palindrome title. Rahul, why is this so important? Why do we want daily metrics?
Okay, small correction. This is streaming of the daily metrics. So you already have metric streams which allow you to stream all the CloudWatch data to whatever data source you want, whether it be third-party providers like Datadog and New Relic, or just to your data lake like S3. And you can stream it via Kinesis data stream that dumps it all in one place. It is incredibly useful to put it somewhere else so that you can seek the data. Now, two things over here really important. One, make sure that you're using the infrequent access with CloudWatch so that you're not paying a ton of money for most logs that you will never end up using. And secondly, use the data streams to get just daily metrics that will actually help you act on important stuff. So this is something that I really like. It simplifies a lot of stuff. It makes it easier to get started with at least daily granularity of your data and take action. So I'd say simplifies. I'd give this 3.5 clouds.
Excellent. All right. I really like what you said. Okay, first of all, big tip, put this on the screen, use S3 infrequent access, or
it's actually CloudWatch infrequent access tier.
Sorry.
And the price difference is dramatic. You would spend, I think, 50 cents per GB for standard tier CloudWatch logs, while you spend 3 cents a GB for infrequent access. So there's an order of magnitude difference in what you would pay for your CloudWatch metrics, most of which are usually never used. So, make sure that you use as much of the infrequent access as possible, and you can always stream out the important stuff as and when you need it.
That makes a lot of sense. Okay, so CloudWatch infrequent access tier, use that. Whenever you have infrequent access, especially for something like this, where you're looking at the dashboard at or near the day, and as that day goes further out into the past, you're probably not going to look at it ever again, unless there's some strange incident that happened that you need some retrospective on.
Correct. Well, there's one other tip that I'm definitely going to add, which is instead of using the default CloudWatch log mechanism, which is basically a string that gets logged, use the JSON format for your logs. The addition of the JSON format really makes it easy to dump all this data into any data store and be able to search it, index it, and make it more useful for the kind of stuff that you do. And most importantly, choose the right logging level. Don't log everything possible for the, don't log at the debug level for everything. Keep your logging level at the right, pegged at the right levels.
That is one of those builder mindset things, right? When you're building it, you think, I'll always need this. One day I will need to reproduce this from the logs, and the fact that I left it on debug is going to save me. But then it's not a educated, informed choice that's looking at, okay, well, if you need backups, you've got backups. And Correct. This is going to cost 10x as much to store this, or maybe more.
Correct.
And also, I really like that suggestion to use JSON. I think it is a law of nature in the computing world that it will be JSON eventually. So you might as well start it as JSON.
Correct.
All right.
Next. So on to the next
article.
one?
Yes.
Awesome.
Amazon Opensearch serverless expands support up to 10 terabyte time series. How are people going to use this, and why is this so important?
Okay, so this almost dovetails into the previous announcement that just came in, right? You can stream all of your logs and such information into a full text search system or a fully indexed system like Opensearch if you need that kind of information or if you need that kind of support. And logs can take up a ton of data, and a lot of Opensearch and Elasticsearch invariably gets used for those kind of purposes. So now that you can actually support time series data, that means you can literally slice the data by time and query by time efficiently is a huge big deal, specifically for logs and other such metrics-oriented data. So I'd say this really simplifies the work for most system developers, application developers, and I'd give this a good 3.5 as well.
Excellent. All right, time series has got a special place in my heart. One of the hardest statistics classes I ever took was the time series econometrics. And it's really interesting because you think for certain time series, you have very regularly spaced data, right? You have a sensor that goes every 5 minutes or every hour or every day. A lot of government data is like this, where you have quarterly data, but then for financial instruments, sometimes you have data like whenever there's a transaction, and then you need to start binning into moving averages, and then you get these really neat statistical models like the autoregressive model and the all the family of ARIMA models, and it's a lot of fun. I spent a lot of time in R that semester.
Time series stuff is definitely very, very interesting. A lot of practical use cases. AWS does have a dedicated time series database, and you should go check it out if that is specifically your use case. But for full text search over time series data and kind of multi-purpose usage like that, I think Opensearch is a really great alternative. And Opensearch serverless is even better because you only pay for what you end up using. So I think that's a great way to be efficient in the way you spend your money.
Well, and we'll get into this later, I'm looking at using Opensearch in my personal RAG system and the RAG for the AWS Made Easy content. And so I'll have to look at this. We don't have 10 terabytes of time series data, even if we took every transcript. That'd be well under 10 terabytes. But it's good to know as the show grows, we could fill 10 terabytes of transcripts. Knowledge bases for Amazon Bedrock, now generally available. So knowledge bases, who's using knowledge bases? What does it compete with? And what are the great use cases that this enables now that it's generally available?
Okay, so knowledge bases is basically Amazon's implementation of a RAG system, right? You've got an underlying vector store, which is basically Opensearch, and it takes up about 4 OCUs or 4 compute units on the vector DB side of things, but it allows you to upload all kinds of different documents into that vector store and query them just like you would out of any RAG system. Now, the configurability of the RAG system is not optimal in my view, but if you were just getting started and you just wanted to experiment with the RAG system, the Bedrock knowledge base is actually really straightforward to get started with. It takes a few minutes. You just set up a new knowledge base. You can start uploading all your documents in there. Or you could literally give it an entire S3 bucket and say, load it all up. It'll load it, it'll analyze it, it'll embed all the chunks into a vector database. And then you can literally use any of the standard, LLMs to query from that database.
All right, how do you rate this one? What's the clouds? And
I actually like it for its simplicity. So I definitely say it simplifies, life for most developers who are just getting started with RAGs. And second, and most importantly, I'd give this a 4 because they've done a really good job of separating out the knowledge base part of it as well as the query part of it. So you can choose any of the latest. Like right now, if you, for example, look at Claude 3, that's available on Bedrock, you can use that to actually query all your data in the knowledge base, and it does really well on most of those queries. So I'd say great way to get started with RAGs, simplifies. I'll give it a good 4 clouds.
And then we will be diving into not just knowledge bases, but the current state of vector databases in the second half of the show. And that's where the interesting to see, what the use cases are, the trade-offs that you're making, and knowledge bases. It can also, similar to embed chain, you can also use other backends, right? You can use Aurora via pgvector.
So that's the vector database part of it. The knowledge base is more than just the vector database. It actually has all the loaders and chunkers as well. So the way I think about the knowledge base is a combination of your loaders, your chunkers, and the embedded database with the API to actually access the data in those with all the queries in place. So it's kind of like an entire platform or an ecosystem that lets you do a lot more than just what the vector database would allow you to do.
Yeah, it's how to put things in, how to query it, the predicate pushdowns that you can do, all of the conveniences that you'd want around the vectors themselves. Amazon RDS now supports IO2 Block Express for consistent sub-millisecond latency and 99.999% durability. Rahul, who should be using Block Express, and when is that price trade-off worth it?
Okay, so now there are very few cases that I can think of, and The first one that comes to mind is financial services, where you need to have transactions that have asset properties associated with them, which means that the minute you commit to a transaction, you ensure that there is durability and consistency of all the data that's committed in. So and when you need that to be really, really fast, so that there aren't any you don't hold up transactions to finish a commit. Those are the scenarios when you need to use this. For most, this would be an overkill, but it definitely makes sense for a lot of financial services firms, which need these kind of massive, transaction volumes happening at the same time. So for most, this is not useful. And I would say, just because you see something bright and shiny come up in the announcements, do not make this your default. You most likely will not need this. Do not, gravitate towards it just because it seems fast, bright, and shiny. It is going to be insanely expensive in comparison to your regular RDS instance with the standard IO. That should suffice for most customers.
In fact, we have a CloudFix Finder Fixer where we go and look for RDS instances which are using IO2 and look at their performance, look at the amount of metrics and IOPS they're using, and if a GP3 volume could cover that, then we can propose that change. So that way okay, if a GP3 can serve, GP3 will not get to sub-millisecond latency, but everything else it can.
Yeah.
So,
and just to give you a level of comparison, your standard GP3 volume has about 3 to 16,000 IOPS. This one has 256,000 IOPS provisioned. So it's at least an order of magnitude more, if not, more than what your standard one is. And so is the price. So you don't want to be spending that kind of money. This doesn't necessarily simplify. It's just great for some of the very specific use cases. I would just warn all customers to not gravitate towards this by default.
Definitely. So we're going to give this a neutral. How many clouds?
I would give it a 3 clouds because this should go with a warning label under it.
Don't use this unless you know what you're doing.
Correct. It's like really one of those. Don't try this at home. We need to have one of those labels. Don't make this your default.
Yes, absolutely. Glad it's there. Probably never need it, but yeah, glad it's there if we need it, if we want it.
Correct.
Okay, next article, Q&A intent now available for Amazon Lex. So what is Q&A intent and what are the use cases of it? How does this relate to LLMs and all of the other ecosystem knowledge bases?
So one of the RAG use cases is Q&A, right? You have a set of questions or queries that you make of a system and you get back a single response. This is not an entire conversation, but it's more a Q&A, single query, single response, which is backed by an internal RAG system, right? So Q&A intent basically marries the knowledge base that we just covered. It marries your LLM for answering a question in a certain form and gives you the interface to actually ask those questions in a simple way. So if someone wanted to just set up a simple chatbot or a simple Q&A kind of solution, this is a great way to get started. You can just load up all your data from an S3 bucket and get started with Q&As. Really simple to get started. I would give this a simplifies and a solid 4 clouds.
It's really neat to see Lex being integrated, right? When you first think, okay, I could directly replace everything with LLMs, but the actual usage is much more targeted, I suppose.
Yeah, correct.
Awesome. Next article, AWS WAF enhances rate-based rules to support configurable time windows.
Yep.
So what is configurable time windows?
Okay, so historically, WAF operated on a 5-minute window. So you could set a rule that said that if a certain thing happens for a 5-minute window, then you take a certain action, right? That's a standard rule. Now, these rules have been expanded to have 1-minute windows, 2-minute windows, 5 was already there, and now a 10-minute window as well. So you can now have rules that span one of these 4 options in terms of time intervals, and you can set the rule accordingly for that. So it definitely simplifies, like there are certain kinds of attacks that you want to identify almost immediately and take action. Others, you need a slightly larger window to make a decision and not, jump to, conclusions immediately. So I'd say this definitely simplifies the life of most administrators. And I would give this 4 clouds.
Awesome. So is this, you have enough time to figure out, is this a denial of service attack, or did one of your services just go viral? And it's actually not. It's just a lot of requests. Okay. Neat. This is great. I'm my first job was in network security doing IP chains firewalls. That was Linux kernel version 2. It is such a complex
it is
ecosystem. I'm really glad there's things like AWS WAF where you can really interact with it at a high level.
I couldn't agree more. This is not something that you want to spend your time working on. It's a time sink, and it's better handled by tools that are completely automated and integrated into your existing ecosystem. So just turn on WAF, set up your rules, and forget about it.
Yeah. All right. Let's take a second to pull up the vector database document.
Okay, while we're getting started, why don't I just give a quick background of, where vector databases fit in, what are the key challenges around RAG systems and why these become important, and then why we are covering this stuff today. So most of us have been building RAG systems to answer some very basic questions, right? We take a lot of the internal data that we have within our organizations, we put them into a RAG system, and hope that the LLMs can then act on that data to give you very context aware or context sensitive responses to the questions that you ask. And the context here is your own personal or organizational data, which is not, which the LLM is not traditionally trained on. So now there are 2 approaches that you can handle this. Number one is you can either fine tune your model with the data that you have, or the other one is that you can build a RAG system. Now, fine tuning does 2 things. Okay, fine tuning is a double-edged sword. On one hand, fine tuning can really help you, do some very simple, very focused problems in a much more efficient manner. So, for example, if you had a classification problem, or you had a very simple categorization problem, having your fine tuning in place where you've trained the data on your data set can make the queries much lighter. You'll use far less tokens, and the latencies of your queries will go down drastically. On the other hand, you have more generic questions, like you would just have conversations or chats with your LLM. That is not something that the fine tuning is really going to help you with, because you will find that the capabilities of the core model actually deteriorate significantly when it comes to a general conversation. Okay, so that's where you want to use a RAG system, or retrieval augmented generation. You want to take all of your internal data storage or internal data sources. You want to make relevant sections of that available to an LLM as part of the context, and let the LLM then use that context to answer the question. Okay, so that's the differentiation between fine tuning and RAGs. Now, one of the underlying pieces of infrastructure that we use in RAGs is the vector database. Okay, now we've spoken about vector databases at length in the past about how they work, and there's tons of material about how they work. But choosing a vector database isn't that easy. There's so much out there in the market, and most of us, when we just get started with simple experimentation, we start with something as simple like a ChromaDB, which is local, is free. You run it on your local machine. But as you start building a production system, it really becomes important that you make the right choices around these specific vector databases, because they are critical underlying infrastructure. Okay, so let's dive right in with the choices.
Yeah. And so again, this is a subset. This is a very busy ecosystem that will only get busier. The ones that we picked were the ones that work specifically with embed chain. Remember, we had Taranjeet Singh on a few weeks ago telling us about embed chains. The ones that we picked are, most of them work with embed chain. They all work with LangChain. There is going to be more added to those lists, on a very short basis.
We are just picking a small subset for right now, because the number of solutions that are available. Can we just bring up the LangChain list of integrations of vector stores? If you can just pull that up, that'll give you a sense for how many options there are. And just like all the AWS services that we discuss, the choices that you have to make here are not easy. Everything from AWS's DocumentDB to Opensearch to Elasticsearch to Google solutions to RDS Postgres that has pgvector enabled on it. They are all choices. Of course, even Redis supports vector data stores now, so that's there as well. So there are tons and tons of choices out here.
And of course, as we remember during reInvent, they're adding vector capability to existing databases. That's also something we're going to talk about is, do you want to use a vector-enabled existing database, or do you want to use a vector-native, built from the ground up, vector-only data store? Let's talk about the pros and cons. Let's talk about the databases. Okay, so I'll put this up on screen. Here we go. So here's a database. The first we're going to talk about is ChromaDB. Now, Chroma is interesting. This one is created when you use embed chain. It will create a ChromaDB database for you behind the scenes, and it will create one. It's almost, would you say it's like the SQLite of vector databases, right?
Yes, I think it's a SQLite.
Okay.
I would definitely say it's like the SQLites. For the most part, ChromaDB works really well when you have ephemeral vector stores where you need, transactionally you want to create a vector store, but it is also powerful enough, like SQLite, to reside on a permanent basis on a file system and operate out of there. ChromaDB is working on a serverless version or a hosted version, which you can access over HTTP. But even otherwise, you can actually run ChromaDB on a separate instance altogether, expose it via HTTP, and have your client connect over the network onto that Chroma database. So it's a lot more versatile than SQLite. SQLite is very specifically a file system oriented, data store, and ChromaDB does a lot more. It's a lot more versatile, and I think it's one of the easiest ones to get started with, because you're not worrying about setting up big infrastructure. You can literally start with whatever is local and get to a prototype or a solution very quickly.
So I'm updating the table here, and we're going to publish this. Easy to get started. As I think the distinguishing feature of ChromaDB, you can import it as a Python library. It's very easy to get started.
Correct. And there are two libraries that you could use. One is to use it as a local file system storage. The other one is to use it as a service. So if you host ChromaDB as a HTTP service, then there's a separate client that you would need to use to actually connect to it as a service.
Yeah, absolutely. Now, one of the interesting things about these vector databases, they all need a way to, well, their main functionality is to search vectors.
Correct.
Now, looking at this comparison, most of them support some variant of what's called HNSW.
Yep.
I'm going to put a little display on the screen of HNSW. It's hierarchical, navigable, small worlds. And so effectively what it is, so say you have all these different vectors, and in theory, you can put in any picture, any blob of text, any video, and it will come up with some vector in the vector space of your model. Now, when you do the key algorithm for many, I guess the basis of comparison is what's called k nearest neighbors. So yep. The idea is you have a vector, say it's a picture of an article of clothing, right? So this is a canonical example, a picture of an article of clothing. Well, to do k nearest neighbors, it has to compare that vector to every other vector in the database in order to see which one is closest, right? So if you have a document on, I don't know, transistor radios and a picture of nature, it's going to compare every single one of those, literally everything, every vector in its data store, in order to figure out, well, which 10 are the closest, whatever you set k to be. So k nearest neighbor is good because it's exhaustive, but as the number of vectors you have grows, it becomes very difficult to do k nearest neighbor just computationally. Okay. So most of these implement what's called hierarchical navigable small worlds, which is a way of pruning the data set very quickly to get to vectors of interest. So imagine you have pictures of things that you could buy if you're a retail store, and you have a vector with a shirt. Well, maybe it'll prune it down to, I don't know, shirts, and then maybe summer shirts or formal shirts, right? It can prune that state space down, and maybe it will miss something because that's where the name approximate comes from. It's not going to compare every single thing in the state space, but it is a lot faster than literally comparing it one to n, where n is everything else you own. Correct. So that's the HNSW. So showing our vector comparison sheet, most of them incorporate some version of HNSW.
Can we switch back to the other document?
Yes.
So we have that comparison.
Here it is. To Great. HNSW. And in order to use HNSW, you need some way of saying, well, how close are these two vectors? I said some databases support different distance metrics. So Chroma supports 3. L squared, inner product, and cosine similarity. So you want to experiment, pick one, pick what works best for you. And this is one of these.
And it's also important to understand that the embedding models determine what kind of embeddings are best suited. So for example, if you use OpenAI's embedding model, the text embedding models, they recommend that you use the cosine similarity because that's what it's best suited to kind of index for or, create vectors for. There are other, models that will also recommend the best, approach that you take. Now, I want to add 2 or 3 more warnings or caveats that everyone should keep in mind. So warning number 1 is when you're mixing multimodal data, that means some of your content is text, some of your content may be audio, some of your content may be video, or some of it may be just images. Do not expect to get cosine similarity or any of these other models working across different modes. Okay, by default, the text similarities will be good only for textual comparisons. The image similarities will only work for image comparisons. But if you're expecting to pull out, use image data and text data in your query, you are not going to get good results. Okay, it just won't work. So if you are basically going to query for images, just make sure that all of your content is images, or default to text. But when you do that, then whether you have audio clips or you have images or you have videos, you have to be able to convert that into some kind of a summary that is text-based that you can then embed so that the similarities can be compared. That way you're doing apples to apples comparisons, not apples and oranges, which make no sense at all.
Or apples to descriptions of apples.
Correct.
Pictures of apples and descriptions of apples.
Exactly. So that's my, warning number one that I would share with all of you. The second one is that when you're changing models, right? Let's say today, the OpenAI's models are some of the best in embedding, or you find that some of the Cohere models are better at embedding. Every time you make a change in your embedding model, you will have to re-vectorize all of the data that's underlying in the RAG because the vector mechanism has changed, right? So you can't have some of your vector embeddings in a certain, using a certain model and then suddenly switch to the rest of them using a different model. You are not going to get good results when you try that, okay? So that's my lesson number 2 that you should always keep in mind. And then the third part of it is, even within the same models, as you go to newer versions or you decide how many dimensions you are actually vectorizing on, even if you change the number of dimensions in your vector, even with the same model, you need to make sure that you're re-vectorizing all of your data. Otherwise, it is not going to work.
I've seen some discussion of basically hacks, like filling in the rest of the vector with zeros, but you basically have to reprocess everything.
Yes.
And so especially if you are looking at web data that may be ephemeral, maybe you want to screenshot it or save it somehow, and that way you save yourself the option of re-vectorizing it later as new things come out. Because if you can't get to the original anymore, then you are kind of stuck with the embedding that you started with. And what we know is that this technology is going to improve. It is improving. So
and it's changing drastically. It's changing every week. So you want to make sure that you have all the raw data also available so that you can re-vectorize it as soon as something better comes about.
Absolutely. Well, the next one on our list is actually a really good basis of comparison. So from one of the lighter options to one of the heavier options, Elasticsearch. So Elasticsearch, it did not start life out as a vector database. And I would say probably 99% of its usage is not as a vector database. So Elasticsearch and its Amazon cousin Opensearch are full text search databases based on Apache Lucene, but they have vector capability added onto it. Now, I wanted to share this great diagram from the Supabase founder, Paul Copplestone. He gave a talk on using pgvector. I think this really summarizes part of the decision you're making when you use a vector database versus a traditional database that already has vectors. Is, do you want to manage 2 different databases and merging that data, including the multiple round trips, or do you want to use an existing database that has vectors added to it? And there's pros and cons associated with that, but definitely on the complexity side, using multiple databases is more complex.
I agree.
So benefits of Elasticsearch. If you have your full text, it is right there, and it gives you the opportunity to easily do hybrid searches where you're doing vector-based searches, but also full text. Since Elasticsearch is extremely mature, it is hosted by the Elastic company, or as we said earlier, you have the Amazon Opensearch, which is very similar, and it had the common root. It is scalable. It is flexible. You can do all sorts of interesting predicate pushdown. So meaning, say, if you're looking at AWS Made Easy episodes and you have transcripts, you can do full text search in Elasticsearch or Opensearch. And maybe you can say episodes, filter by episodes who have guests, or filter by episodes with between 70 and 80, if you're looking at that era of episodes. So this will support that type of what we call predicate pushdown.
And I think that's a great segue to talk about my next big tip, which is you can't just rely on the vector data and the vector distance data to actually get good search results out of your vector store. As your data set increases, you will find that the overlaps or the cosine differences or whatever other metrics that you use for distance, those will all start failing. Okay, you'll start finding a massive amount of overlap between these vectors in the vector space, and you will start struggling to get good relevant content out of your RAG. So the next big lesson is to always ensure that you are adding more metadata to your vector store, because there is some context sensitive metadata that only you know and only your organization knows, that is incredibly valuable to have with the vector embeddings, so that you can filter on them just like a regular database or a regular data store. For example, if, like we were using the examples of the shirts, right, or brands like that. Now let's say you only wanted to search for items from a brand name like Zara, right? That could be in your metadata, and then you only pull out vector embeddings for the brand Zara. And that way, you're not doing vector searches across the massive space. You're just doing vector searches or the vector distance between all the vectors for shirts with the brand name Zara, right? And
or
that you can do
search,
as a filter layer on top.
or shirts that are in stock in my size. Right?
Exactly.
I don't care about a shirt that existed 3 years ago in a small. That
Correct.
is as
Exactly.
irrelevant as it possibly could be.
Correct. So I think to get good quality results, specifically at scale, you really need to be able to marry the vector search with a metadata filter, so that you get to a more scoped set of vectors that you can pass on to the LLM.
Yeah, absolutely. And
So
I think it's the same with all new technologies. Is when you get excited and you think this is going to completely replace the previous thing, and then you end up settling in a happy medium where the hybrid is the right thing, right? Just like maybe if we ever get flying cars, they're probably not going to replace regular cars, but you'll probably have use cases for both. That most technology, it's not a replacement, but it adds to the broader ecosystem.
I agree.
All right. Next database we wanted to share is Pinecone. Now, I haven't had a lot of experience with Pinecone personally, but I found this really interesting comparison by a group called VectorView.ai that I put on the screen. Now, Pinecone is the first one here that's interesting, that you cannot self-host, as far as I know. Pinecone is only managed. It is not open source. So similar to Elasticsearch, that's not open source. You cannot self-host Pinecone, but apparently has a really, really good developer experience. Rahul, what's your experience with Pinecone?
Yeah, so Pinecone was one of the very first vector databases to come on the scene. They became incredibly popular as people were looking for, massive embeddings. And, at that time, I don't think Elasticsearch or any of the other tools had vector embeddings in, as a feature. So Pinecone was a great hosted service where you could just use it out of the box. They would do everything for you, and you could get results. You could get started very, very quickly. Now, Pinecone also was not too expensive to get started with in comparison to everything else that was available. But now the space has gotten so competitive that you do really need to understand the kinds of indexes it supports, the kind of distance metrics it supports, and see if it is the right choice for you. There are a number of use cases that we've come across where Pinecone doesn't really fit the bill for us. So evaluate it for all of those aspects. And I think that brings me to my next tip. I think with every database, there's going to be a new tip that I'm going to recommend. So the one thing that I find that most RAG developers don't focus on is writing the equivalent of unit tests for their retrieval. Okay. Now, for all the functions, all the code that we write, we all write unit tests, right? It's become a standard just to make sure that for a given set of inputs, whatever system is, kind of processing those inputs, we are validating the outputs that come out. We actually don't do any of that for our retrieval part of the system, right? And invariably, you'll get all kinds of crazy results that come in from your retrieval. And because the retrieval is a part of a longer chain of things where inputs are coming in, you have ingestion going on, you have retrieval, then you have LLM that's using it as a context, and then generation of the output. There's a big chain. If you can't ensure that the relevant information is being extracted for the query that you are putting out there, then your RAG vector DB is kind of useless. So you really need to create a data set that you are using for testing. You ensure that it is vectorized. You then have a set of queries that you run against, that data set that's vectorized or embedded, and make sure that the most relevant data is actually coming out of the solution. You should measure your hit rates, you should measure your success rates, you should measure the relevance of the chunks that are being reported back as a unit test. So if you're not doing that, then you're basically just tossing a coin and hoping that the results that you're going to get are going to be relevant.
I put something on the screen. There's a really neat website called ann-benchmarks.com where they're trying to figure out, they're focused on speed, but they have websites where they actually have training and testing data to, like you said, to understand the accuracy, pre-labeled, okay, what should the nearest neighbors be for a particular query or for a particular vector? What should the nearest neighbors be, right? If I have a very strange purple shirt and there happens to be matching purple pants for sale, well, I hope that's in the nearest neighbor's result set, depending on the vectorization. So what this is showing, and this is an interesting way of comparing search algorithms, this is showing queries per second on this axis, and then recall. So you want recall to be higher. So this is the fraction of true nearest neighbors found on average against all the queries. So again, remember we talked about k nearest neighbor, where it's finding all of them, right? It can literally enumerate every other vector in the data set and then find you the top 10 or the top 50, whatever you asked for. Whereas ANN means approximate. So because it is kind of pre-subdividing the space, it's going to approximate it. And that way it doesn't have to look at every single last combination. But it's neat. You can look into these data sets, see how they're constructed. So
I would also just warn that the only thing that I would actually warn against, users, I mean, definitely take a look at this, but make sure that you create a data set and a test set that is specific to your kind of data, because your kind of data might not match the data sets that these guys are using. And it is very context sensitive. Your data might be drawn from, PDFs, might be drawn from data. Actually, here's another experiment that you can try to understand this better. If you take a standard loader for a PDF, so take a text, okay, take 1 page of text, save it as a docx file, save it as a PDF, save it as raw text, and save it as a screenshot or an image. And use any of the loaders. Use a LangChain loader or embed chain loader for it. And then take a look at the vector embeddings that come out of it. You'll realize that they're completely different. Even though it's text in a PDF document, the way it vectorizes is completely different from the way the documents from a docx file with the same content are going to get vectorized versus raw text. Because the loaders are different, they do different things with the data, and the way they end up chunking that structure is going to also be very different. So you should not expect that even though the text is the same, just because the formats in which they are stored in a raw manner, you will encounter situations where their vectorization is happening in a different way. So make sure that you are actually creating test sets based on your data, the way your loaders are going to work, the way your chunkers are going to work, and make sure that your queries into the vector database are pulling out just the most relevant chunks to pass on to the LLM.
And that you are doing your strategy is set up in such a way that your vectors have sufficient separation within that space.
Yes.
So say if your entire subject matter is about a very esoteric sport that very little is written about, it might be the case that all of your vectors are then really, really, really similar. And so you need to figure out a way of augmenting with metadata, and also with augmenting with metadata. How do you differentiate things within that sport? So maybe, for example, you're really into, I don't know, potato sack races, right? Something really esoteric, and you have strategies about burlap versus nylon or something, and within that universe, maybe people really care about these two things. But zooming out to the entire universe of things that could be vectorized, they're all right there. And so you need to figure out, how do I separate that out so that I have interesting and good responses within your domain? And so that means having domain specific test sets that work for you, so like you said, you could evaluate your approaches. Right, just because there's something that's on the leaderboard in general, right? They might be talking about New York Times articles, and that might have very little to do with your use case.
Correct.
All right, we've got a few more on this list. Opensearch. This is interesting. I linked to an Amazon blog post where they actually support quite a few different search algorithms within the vector space. I linked to that. There's NMSLib, which is for HSW. They have another thing called FAISS, FAISS, which is Facebook AI search.
Semantic search.
Semantic search. There we go. Yeah. They have Lucene, KNN. Lucene is kind of like their original search engine by Apache. Underneath this, it has basically the same benefits as Elasticsearch, but on Amazon. So you're going to get that scalability. You're going to get the same pricing. It's not another vendor if you aren't using Elastic. Correct. If you're already in the AWS ecosystem, I could definitely see that being a choice. I'm running Opensearch on Docker locally for some testing, and then I'll migrate that over to Opensearch serverless as that grows. And remember, Opensearch serverless, it is still pricey if it's like a personal RAG, because there's a minimum unit that has to be running, and so it ends up being what, $400 a month minimum.
Yeah, it's about $400 a month, given given that there's a minimum number of compute units that get used. But here is again the next tip that comes with this. So invariably, you will find that raw or naive vector searches are not going to be enough to actually give you really good, relevant content. In a lot of cases that we've encountered, we've found that a combination of a vector search married with context that comes from keyword search, that tools like Elasticsearch and Opensearch are really good at, marrying those two as part of the context really helps. Now, what you might want to do is get your vector search data, get your Opensearch or Elasticsearch data, and then do a re-ranking on top of that to find the most relevant content, and then pass that on to the LLM. And that we found to be way better in terms of outcomes versus just going with the vector search alone. So you need to figure out what works best for your data sets. In a lot of cases, when full text search or semantic search is really good and you can actually get really good data out of that, then that just helps find all the right documents, and you can use that as context as well.
Definitely. And even if everything that you're doing is in the image domain, right, the same thing still applies. And I will post a link to the talk by the Supabase founder, Paul Copplestone, where he gives a great example of using Postgres pgvector for to hold vectors of images.
Yeah.
Okay, covering the next three on our list: Qdrant, Weaviate, and Zilliz. Zilliz being the hosted Milvus. I wanted to put this back on the screen, the Picking a Vector database site. So these are very similar in their offering. They're open source plus hosted option. They can be self-hosted. They are vector first databases, and then the metadata part is added on second. So these are purpose-built vector databases. Correct. So if you are bringing a lot of data to this, you will probably have to integrate it with an existing database, or you will have to figure out how to get, if this is your only database, you have to figure out how to get everything else into the metadata model offered by these. Correct. So that's a bit of, and these have not been around that long, so they're not going to be as mature on the database side. Right? A lot of databases like Postgres has been around for 30 years.
Correct.
And Elastic and Opensearch, not quite that long, but still a long time. So you might not have as much flexibility on the non-vector part of it.
Yeah. So I think I'd like to jump to my default choice for a production system.
Yes.
And that is using pgvector on top of AWS Aurora Serverless. And I'll tell you why I picked that. Number one is a lot of data is typically lying in these relational databases already. Second, Aurora Serverless is completely managed, and it is serverless, which means that you only pay for what you use. So it will go down to half an ACU or an Aurora compute unit at its minimum, and it'll scale up to whatever you need for that particular instance. So it's a really, really neat way to efficiently use the resources only for what you need. And it also means that for a lot of cases, you actually don't need a separate database. You can actually make it multi-tenant by simply adding new users, and each user has its own schema that's operating in the database. So you can make it multi-tenant by default just by having a number of different users have their own accounts. And so in my opinion, when you have a number of different users using multiple different databases, you can pack them all into one single Aurora serverless instance and just be very, very efficient the way you actually use the resources. And that would be my recommendation for any production system.
Yeah, it definitely simplifies a lot of what you're doing. Again, I'm putting this Supabase talk back on there. Supabase is another hosted Postgres service. But the idea is if you're already using Postgres, then you can use its vector capability, which is maturing. Yeah. The HNSW search is basically now table stakes for any vector offering, whether it is a vector database or just a vector feature. pgvector was developed with these folks, plus the AWS team, plus the original person who started the package. Like the pgvector extension has a lot of support behind it. Yeah. Plus you have the maturity of a 30-year-old database for all of the predicates that you want to use, and even cool stuff like PostGIS, right? So you could have geospatial metadata, right? Give me images that were taken. Say if your images have EXIF data that has GPS coordinates, you can have a geospatial bounding box and then search for images of puppies in Washington State, right? And that would be hard to do with other languages. Or give me images of puppies in this zip code. Right. That would be hard to do in other databases. Or images of puppies within 10 miles of my house.
Correct.
Right. You can do all these kind of neat things with that you could not do with these other databases, because Postgres has a lot of other mature extensions, and it's generally very like I said, it's a highly optimized ecosystem, and you won't have to worry about scaling. With Aurora Limitless, you can.
Aurora Serverless is limitless.
Yes. Well, I thought, what did they have? The Aurora, what did they call it? The Aurora, there was a use of the term limitless. Yeah, Aurora Limitless tables.
Yes.
Aurora Limitless database. So you can scale Aurora clusters as much as you want. Okay, sorry about that. Let me share one other few kind of closing thoughts. I thought this was a really interesting comment on Hacker News, which said everyone I talk to who is building some vector database thing sooner or later realizes they also care about features of a full text search engine. They care about filtering. They care about direct lexical matches, paging, groups, facet counts. Vectors are going to become one feature of that.
Correct.
And it says vector search is not exclusively in the domain of text search. There's always image and video, but pre-filtering is important since you want to reduce the set of items to be matched on. And it feels like Elasticsearch or Opensearch are faring better in this regard. Mixed scoring derived from both sparse and dense calculations is also important, which is the strength of Elasticsearch and Opensearch.
Yeah. Another example of a tool that's really useful here is Kendra, because it does full semantic search and it can pull out the documents that you want, and then you can filter your vector search output based on that as well. That's really useful.
Yeah. Then finally, I'm putting this little dedicated vector databases versus databases that support vector search. There's a little infograph here, and it's dividing it into Opensearch and commercial on one axis, and databases with vector search versus dedicated vector databases on the other axis. So have that there. I'll post a link to that in the video description. All right. We're going to do the third half of the show. Oh, interesting. 1 second here. I have an Alexa feature at 9 o'clock. This power outlet turns off, and I repurposed this power strip for something else, and I don't want it to turn off at 9 o'clock. So I need to go and delete that Alexa rule. My monitor just turned off and my laptop screen went dim.
Okay, now for the last part of our show, and not the least for certain, we have a new Finder Fixer that we're releasing for CloudFix. And this is the EMR auto shutdown, right? It's basically identifying idle instances for EMR and shutting them all down. Now, it's really easy as it sounds, but a little more complicated in its implementation. Stephen, tell us more about it.
It was funny that my lights just shut off according to a timer, because that was the desired behavior. We want to do the same thing for EMR. We want to make sure that if you're not using it, it shuts down. All right, let's dive in and I'll show you how it works. Okay.
Great.
And then now it's been great.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry, because CloudFix fixers are AWS recommended and easy to use. It's the only tool that fixes cost savings opportunities and doesn't just find them. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part is that it works non-stop. See for yourself. Click on the button to get a free demonstration of CloudFix and stop overspending on